Hi, welcome to Conquer the Concept, and in this video we'll be discussing about trigonometry ratios. So here we have a right angle triangles with sides of 3, 4, and 5. We can check to make sure that this is the right angle triangle using the Pythagorean Theorem, which is a squared plus b squared equals c squared. So 3 squared plus 4 squared equals 5 squared. If this equation is true, then this is a correct right angle triangle. So 9 plus 16 equals 25. 9 plus 16 is 25, and 25 is equal to 25. So this is true. And this is a 3, 4, 5 triangle. So we can now identify sides 3, 4, and 5 with a distinctive name. You might know that side 5 is called the hypotenuse. And the hypotenuse is the longest side in a triangle. Now, if we're discussing the triangle sides in the perspective of angle A, which is the top angle here, and with angle A, side 4 is called the adjacent side because it's touching the angle A. It's forming basically the angle A, and we can call side 3 the opposite side. This is because 3 is opposite to A. So we have the opposite, adjacent, and hypotenuse in perspective of the angle A. So we have three trigonometric identities that we're going to discuss in this video, and these are the most basic. So we have sine, and sine is basically the ratio of the opposite, so opposite to hypotenuse side. So you would, if someone would ask, oh, what is sine in this triangle, you would say sine is equal to the opposite, which is 3, to the ratio of the hypotenuse, which is 5. So sine is equal to 3 over 5 for 0.6. So like this. And then if the next ratio is cos. And this cos is equal to adjacent over hypotenuse. And this is equal to the adjacent, which is 4, over the hypotenuse, which is 5. So 4 to 5 is 0.8. And then the last ratio is tan, or tangent. And this is equal to the opposite to the adjacent, which is equal to 3 to 4. So 3 over 4 is equal to 0.75. So if someone would ask you for sine, cosine, and tangent, then you could just give them these values and you would get the problem correct. There's a helpful saying that we can use to remember the sine, cosine, and opposite, like the ratios. So sine, you can say it by remembering so, ka, toa. It's like so, ka, toa. So so is equal to sine. This is opposite, and then this is hypotenuse. Oh, hypotenuse. And then so sine is equal to opposite over hypotenuse. Cosine, which is if we go to ka, is equal to adjacent over hypotenuse. I'm abbreviating the opposite, hypotenuse, and adjacent to make it easier. And then the last thing, toa, is equal to tangent is equal to opposite and then adjacent. So if you remember SOHCAHTOA, toa, it makes the process much more easier. Let's try another example. So let me just draw a right angle triangle. And this time we'll do this as a, remember to figure out which angle you're identifying the sine, cosine, and tangent from, as that is vital. So this time we can have a triangle of sides, let's say 20, 21, and 29. So you can try the Pythagorean theorem on this triangle and see if it's a triangle. It is, because 20, 21, 29 is a Pythagorean triple. So if someone asks you what is the sine, so the sine is equal to, if let's go back to what we're saying, so, which is opposite over hypotenuse. And in this case, let's identify the opposite, hypotenuse, and adjacent. So hypotenuse is always the biggest side, which is 29. And so that 29 is the hypotenuse. Adjacent is the side that touches the angle A. And so therefore it's 20. And then opposite is like the opposite to angle A, which is 21. So sine is equal to opposite over hypotenuse, and then opposite is equal to 21, and then this is equal to 29. So that's the sine. And now cosine, if we go back to what it's saying, is equal to, ka is equal to adjacent over hypotenuse, and adjacent in this case is 20, and then hypotenuse is 29. Now our last one, tangent, if we go back to what it's saying, is toa. So tangent is equal to opposite over hypotenuse. Tangent is equal to opposite, which is 21, and hypotenuse 21, and then hypotenuse, which is 29. So we have now identified the three ratios, and this is a really helpful tool, as it's like a foundational skill when you're progressing with later trigonometric skills and algebra 2. If you learn from this video, please like and subscribe to Conquer the Concept. Thank you.